The real estate industry is the world's single largest contributor to climate change. At Fifth Wall, we're on a mission to help the industry eradicate its carbon emissions and build to zero. Well, Ryan, thank you so much for joining. Thrilled to chat with you, thrilled to be investors. And what is that beautiful city view behind you?
Oh, I don't even know. This is just like it's high tech. It's, the sun's rising, the future is optimistic. A marketing person came up.
I feel like the sun's coming in very glaringly on this side of me. So there's a accidental congruence here in our lighting.
I normally have Burning Man as my background for all my meetings, but I figured your real estate folk would, want to see something closer to home.
You might be surprised. But anyway, I want to talk just quickly about your background and how you started Turntide. You've had such a diverse career, right? Across investing, obviously a lot of experience in and around the energy sector. But can you just walk through your career arc and how you got to found the company?
Yeah, thanks. I would describe, to help understand some of how I got here, there are a few pillars that were really early in my life. So it's important to pick your heroes wisely when you're young. And first, I learned about nuclear fusion when I was about 11. It was actually from a little documentary that's Ben Affleck's first acting break called Voyage of the Mimi. So that's people of our kind of age and generation probably grew up with it in school. So nuclear fusion, here's this thing that's like high tech, save the world, clean energy, unlimited, like the sun, end pollution. This is a very big goal, and it sounds much easier than it is. And so that was kind of the first real spark of wow, it's possible that we can solve these huge problems with enough technology. And then I realized you needed a lot of capital if you wanted to go solve these kind of problems. I had a pretty practical father, and so I read all of Warren Buffett's investor letters when I was probably 12. And then there's this other guy named Ray Kurzweil, who I would say has articulated the generalized version of Moore's law, and how one of the most predictable things in all of human development is these exponential price performance curves of computing power. So Mark Andreessen in an op-ed said software is eating the world, compute is eating the world is more accurate technically, but this is like the most unstoppable, most predictable force of virtual human development. So you take clean energy, compounding, capital needs to build things like Buffett, and then this concept of exponential technology. This was sort of the seed for me of okay, I sort of have this core idea of how I want to have an impact pretty early. And so it's funny, I was not in the real world for a while. I was a national champion rower and road cyclist. So I sort of figured, hey, I'm only young once. I'm going to go do this other thing in the business world and energy world to be there when I get back. And so I went through school as an engineer, but I think the thing that I was always really fascinated by, it was interesting. I thought, and this has a bit of overlap with Fifth Wall, I had always thought Silicon Valley had a bit too much of kind of a lottery ticket, level of uncertainty where you hear about these amazing technologies, but you also don't hear about 90% of companies that VCs fund fail. And I have a quote that I love from Charlie Munger, Warren Buffett's partner. Just tell me where am I going to die, and then I'll just never go there. And so this idea of working backwards from failure modes has sort of pervaded a lot of my thinking. And the way that I've expressed that in different companies is go into proven industries. So there's lots of revenue, companies are already there that have very high barriers to entry. So this is kind of the Buffett mindset of hey, what's going to be around 10, 20, 30 years from now, and see that very clearly. But then where can you apply these exponential technologies? So if you think of things like in, maybe your market in real estate or in industrial technology, things that have very high reliability requirements, very, very, very difficult to break in as a brand new startup. You have to have either that very deep science that just takes 5, 10 plus years to develop. There's no shortcuts. So I like these things that are kind of, there's no shortcuts, and they're just very hard, because a lot of people get scared of hard problems, but they can actually be very predictable if you dedicate
And it
The
creates, I imagine, a barrier to entry as well. There's a scientific and structural barrier to entry once you cross some critical threshold, right, of differentiation.
Yeah, exactly. And the problems are clearly worth solving, right? Because you know the target, like you know how much energy is being used for, what the problem is in advance. The thing that it exposed me to that led to Turntide was there's this other motor architecture called a switched reluctance motor. And it's been around for a long time as a concept, but you could think of it as like the simplest possible mechanical motor that can be made, but it's very hard to control. It's sort of like trying to ride a bicycle backwards, mechanically unstable. My software engineering background, it was totally obvious that this was a class of problem that if you could throw enough compute at it, like the make the software eat the world, this should be solvable. And then I came across this company in Silicon Valley at the time called Software Motor Company. There was about 10 years of R&D work that had really just proven out to work. So, the timing, when I met them, it was right around when they solved that. And so the core R&D people are still with us, but they had proven that this could be made, in fact, as the most efficient motor possible. Like that was sort of theoretically possible, but nobody had actually taken over the finish line. And so, in the last 4 years, we've gone from an 8-person kind of R&D group to about 150 people, and really, really scaling now and having an impact.
There's a whole lot of just non-intuitive statistics about how critical motors are to the economy. And I'll just go through some of them. And I'm curious if you can kind of unpack some of these, because I think this will surprise a lot of people. One is just the sheer quantum of motors that are out there, right? Like, I don't think about motors really in my everyday life, but they are everywhere around me, right? They are powering everything that makes my life and the global economy possible. So just how many motors are there in the world? The second is how much energy they consume. Like, they consume almost half the world's energy, and no one thinks about them. And then lastly, how much of that energy is wasted in the existing motor design. So can you kind of just unpack some of those statistics for people? Because I think it'll surprise our audience.
Yeah, so motors are kind of the hidden champions that really, literally anything that moves in civilization, there is almost by definition a motor, either rotating or linear motor behind that. So lighting is very visible. It's in the room with you. It's only something like 10% of electricity is lighting and computer screens. Motors are half of all electricity. I don't know the exact number of motors because it's kind of a power law. Like you can have megawatt large motors, and then you can have the little ones spinning your hard disk drives that are using the micro milliwatt or something. I think the number I heard is like 19 million made per day or something like that.
19 million motors made per day.
Yeah, around the world. It is obviously numerically a lot of those are the really tiny ones that are small devices. We're focused on the bigger ones that kind of 1 horsepower and above that are in more commercial systems. We'll eventually get into some of the smaller ones. The core technology applies to that. And when you look at the energy consumption, it's it's like an 80-20 rule. Like 80% or more is from the 1+ or 3+ horsepower motors, because obviously something using a million watts versus 1 watt, it's got a much bigger footprint. But yeah, half the electricity in the entire world. So like all of the power plants and all of the dams and everything on the generation side are now solar panels and wind turbines. The other side of that electricity wire is a motor, half the time for the electrons, and it's over $1 trillion a year of electricity, just for order of magnitude. So when you talk about waste, I mean, I think it's funny. I'm Canadian, so I'm like sort of ambivalent on global warming, but like really dislike pollution. So I'm like, yeah, I definitely want lots of energy consumption, but I want it to have a purpose. Waste is just such a sin, right? And so the idea of, you have, it turns out about half of the electricity of this $1 trillion is getting wasted. By the way, just for context, like 80% of the energy that goes into cars today, internal combustion engine, is wasted. So motors are already better. Electric motors are already much better, than combustion vehicles. And that's why we need to decarbonize the economy, because it's not just, carbon that's bad, but it's like the systems are very inefficient. But so electric motors, let's say about half of the energy actually gets used for its purpose, and you're never going to make that 100% because there's physical limits, to thermal losses. But you can certainly make the motors run at the speed that they need to accomplish their goal. And I mean, just as an example, you take HVAC systems. Most of the HVAC systems in the world, like in the US, I think there's 20 million packaged rooftop units, and 18 million of them, the main blower motor, the fan that circulates the air, runs at full speed all the time, whether it needs to heat, cool a lot or a little. And it's just totally wasteful, but it's like cheaper to build the system that way up front, because having variable speed is complicated for motors. You need a fairly advanced electronics for any motor to change its speed, actually. And yeah, so I mean, there's just sort of inefficient physics, and then unintelligent controls or lack of control completely are ultimately it's a half a trillion dollars a year problem.
Wow. And when you think about that, say $500 billion a year problem, if you were to explain why Turntide is better, is superior to the existing motors, right? Some portion of the 19 million motors that are built every day. How would you explain that, just in simplistic kind of layman's terms?
Yeah, so it's the nature of technologies that have more information processing at their core. So there's no free lunch in engineering, but what's amazing is you can substitute mechanical material cost and complexity with more information processing. And because bits are abstract, like think of Amazon, for example. Amazon could not exist without all the computing power. You couldn't reduce the footprint, the retail real estate footprint, or transform it without the power of computing. And so really it's the first time that there's truly an architecture that can take advantage of all these big tailwinds from Moore's law. So we can strip cost and material out of the system, both to build it. We don't use any like magnets or rare earth metals or anything that other high efficiency motors need. They're expensive, and you got to dig up a jungle or something to get the materials. And you're replacing that with computing that obviously keeps getting exponentially better and cheaper, and has a lower physical footprint, environmental footprint. So that's really the key ingredient that we're doing, is we're leveraging that to make a motor use less energy and use less materials to build it in the first place.
Got it. And for real estate owners, like I think for most real estate CEOs, it again would be pretty non-intuitive to them how many motors exist within their buildings and how much energy those motors are consuming, and in turn, how much energy those motors are wasting. So when you think about the applications of Turntide for the commercial real estate industry, how should a real estate owner be thinking about it? And how do you think about approaching deployment into commercial real estate assets?
Yeah, it's an interesting problem. So, I mean, in general, motors in buildings are going to be, half or more of the. I think the DOE stat is like 40% of all building energy is going into HVAC, and behind that, most of that's going to be motors. It's certainly a bigger footprint than lighting, 2 to 3x. It's usually like on the roof or in the background, so somebody is not necessarily thinking about it. And I think historically too, it's not been an area that could be necessarily addressed. So somebody, buys a building or builds a building, the HVAC is just spec to whatever the kind of minimum regulatory requirements are. I think there wasn't a lot of thought to, hey, could we make this more efficient? Real estate's an interesting market. You end up with all these sort of agency costs, and in the built environment, I think you have a real need to coordinate, the different decision layers, because the person who builds a building isn't necessarily the one who's going to occupy it and pay the electricity bill. And so just these are the kinds of things that this touches a lot of. It's a complex problem, and you guys are sort of in the middle of all of it, which is very cool. but yeah, having number one, the awareness, and the regulations are going to be really ticking up. Like I think New York City just this last year started putting kind of an energy health code thing on the requirement on the building as an example. And so that's bringing to the surface, hey, what is your HVAC system doing? What are the pumps doing? What are the motors that are getting the water up 50 flights of stairs to the tap? I mean, if you ever walked up 50 flights of stairs, it's a lot of energy, and that's a motor turning that pump to make the bathroom work at the top floor. So there's a lot to first uncover before you can even address it.
Yeah, I think what's kind of again non-obvious to a lot of real estate owners that have been in the business of owning commercial real estate is actually how complex these things we call buildings are. I think the construct, the mental and the financial construct of how commercial real estate owners have operated their business is, yeah, I build a building or I own a building and it's got a roof, it keeps the rain out, it's got some doors, got some security, keeps the bad people out, it's got some lights, keeps the lights on. But the actual conveyance, the provisioning of that is far more complicated. And the nexus of that with what we think of as like smart buildings and industrial IoT and a lot of the requisite systems that support that, these real estate owners are now having to learn, and they're having to learn it fast because of new environmental standards, because of making buildings smarter and more functional. And I know that you've had a big pilot with Amazon. Can you talk a little bit about that and what kind of some of the learnings have been from that pilot?
Yeah, no. So Amazon, they're an investor of ours, and obviously has a massive physical footprint. Just because they're a big company. I mean, they're probably per square foot more efficient because they don't have all the showroom space compared to other retailers. But we're working on the HVAC systems first. So our core product today is HVAC systems. We're starting to work on some data center areas as well. Like actually one of the motivations originally was starting the company was to make data centers, because cooling is such a huge component there, make that more efficient. But yeah, so their fulfillment centers have very big HVAC footprints, as you'd imagine. They're large buildings. And so our standard product is we are upgrading the main ventilation motors so that we can make them, number one, run more efficiently, and number two, run at a more intelligent speed, because you're not always at full capacity in the building. It depends on the temperature outside. And so you're just wanting to use the energy that you need. And I don't know if we've got the final numbers back from the Amazon piece, but we're on average for the systems that we're doing, like they're fairly there's quite a bit of standardization for these kind of larger, flatter buildings, like a fulfillment center, like a retail store, and they use these architecture called package rooftop unit, and we've seen a 65% average reduction in energy. It's pretty consistent. It's usually between 60 and 70% for these things. So I mean, this is this is a huge improvement. I mean, typically we're seeing like a 2 to 3 year straight line payback for an installation. So it's sort of similar or maybe even better than LED lighting upgrades. And we're looking to see a lot of maintenance benefits too, because we can sort of more smoothly ramp up and down the equipment. Our intelligent controls, we're starting to get into more predictive maintenance. So really energy and service cost reductions while improving uptime is sort of the key buckets. But yeah, Amazon is I've got to say, like, I'm really impressed with what they're doing. I mean, they're genuinely committed to this climate pledge, 10 years ahead of the Paris Accord. I mean, they're really investing very heavily behind doing that stuff and taking it seriously.
Yeah, it's awesome to see, right? A large corporate, one that clearly has its own environmental issues and negative environmental contributions by its own admission, not just talk about sustainability, but actually invest money right into solving some of the core problems and actually deploying technologies like yours. And one of the interesting things, I was just looking at some of the background, which is really interesting stat. If all the motors in buildings could be replaced with Turntide technology, it would be the equivalent of reducing carbon emissions by 2.3 gigatons of carbon per year, which is adding 7 Amazon rainforests. And so I guess one of the questions I have is, that's profound, right? Like at a at an environmental level, at a consumer surplus around energy and the economy level, that is profound. How do you think about telling that story, right? It must be a challenge to go from I build motors and I have a more efficient motor to I have the potential to add 7 Amazon rainforests, right? That is a that is a chasm intellectually and logically to cross. How do you think about selling that? And I'm asking in particular, if you were selling into the real estate industry, how would you position that sale?
Yeah, I think it's an interesting question. I mean, all these climate change, all these things can involve such big numbers that they just seem so distant from anything you can relate to at a human scale, right? I mean, so people have looked at a map. Hopefully, the Amazon rainforest is pretty big. So to have another 7 of those sequestering, sucking out carbon is hopefully a concept of the magnitude of this. I don't know if you can see my shirt is our mascot. We call Bone, so it's a T-Rex fossil. So I measure they're, let's say, 10 tons. So I measure everything in terms of how many T-Rexes are we not digging up and burning because they've been through enough already. So like one HVAC upgrade, a typical kind of 3 horsepower motor will be the equivalent of not digging up and burning a T-Rex of carbon over its 10-year life or something like that. So that's like a more human scale. But I mean, for real estate investors, they're pretty practical people, so it's usually not an emotional sale. It's usually more, okay, what's the ROI and how does this translate into asset value? I mean, the two big things, depending if you're the asset owner or you're the operator, if you're the operator, rough numbers, a $2,000 motor might save $700 to $1,000 a year of electricity. So you've got a 2-3 year payback typically. If you're the asset owner and you're getting a multiple, say a 5% cap rate is a 20% multiple on your operating income. And so if you're taking responsibility for the energy bill and you lower that by say $1,000 a year, that's going to increase your asset value, 20x that, right? So I mean, I think those are some of there's like pretty clean math around it. I mean, the nice thing with motors compared to some other energy efficiency things is that it's pretty black and white. It's pretty concrete how much energy you're saving. I mean, ROI or asset value increase are kind of the two clear ones if you're whether you're an operator or an owner. Obviously, if you're both, both.
I always ask people when I interview them, what's cause for optimism, right? I think when you talk about sustainability a lot and when you talk about the climate crisis, there's kind of a reflexive reversion towards pessimism and the negativity around this. When you just look at your company and some of what you're seeing from market response, from investors, from the public, what gives you cause for optimism, right, around our capacity to solve the climate crisis through motors or through other means?
Yeah, I would say at a high level, why I'm optimistic about kind of the world and this market that we're in general is for the first time, really just in the last few years, maybe 3 to 4 years, there's not a compromise to be more environmentally friendly or to be a better business person. It's the technologies are following these highly predictable cost curves. Again, if you can leverage this information technology architecture component, it's just going to be cheaper and better. And so it's the free market forces are really starting to kick in. 12 years ago or 10 years ago, if you wanted to have solar on your roof, you kind of did it to be cute, but it did not pay for itself. I mean, it was an infinite payback, or was a 20-year payback or something. Now solar on the generation side, I think is cheaper than coal for generation, right? Our motors use less raw materials to build than even a standard low efficiency motor. Let alone the high efficiency motors that use these very expensive rare earth materials. So, and LED lighting is sort of the same thing. It's just cheaper to operate over its lifetime. So, the economic forces are really kicking in. This is all because of technology development that can leverage more computing power. And then certainly on the policy side, I think there's been a lot of improvements. I mean, this is not an area I'm an expert in. You probably know more than me, but having so I'm obviously a fan of free market capitalism, but you really do have a need for regulation to expose problems that otherwise wouldn't happen on their own. So you think of like fuel economy standards, that you want regulations to make the playing field level, but if everybody has to raise the fuel economy, then that's going to expose some of the hidden costs because people, just didn't even realize it before. They weren't, there was no incentive to make these better products. And in the built environment, I think you're seeing a lot of that sort of intelligent regulation kick in as well. And just the overall awareness. I mean, people, the customer side, people get it. I mean, like 10 years ago, you had to search, somewhat hard to find the sustainability person at the company. And now it's like on the front page for everybody because they really get, hey, our consumers are going to leave us. I mean, if we're really not addressing this head on, and oh, by the way, if we're intelligent about it, we'll actually make money and save money by doing this stuff.
What I'm hearing you say, and what it feels like, and I hear this, by the way, from a lot of entrepreneurs in the space, is that, historically it was that one's environmental, ethical, altruistic sensibilities was the main driver of whatever action taken, right? And that was not necessarily coincident with what was the most financially expedient thing to do, right? Which might be to just, do the old polluting stuff that you were doing. And today, these cost curves, technology curves, various laws that you've referenced have progressed such that we're at this inflection point where now one's environmental sensibilities and one's altruism can in fact be coincident with what is the right thing to do, what is the appropriate pricing of these environmental externalities, and what can deliver a consumer surplus in the form of less energy consumption to produce the same economy that we all want to continue the progress of society in the world. And it's actually really inspiring to hear. And I think what's also interesting is when I think about, commercial real estate, owners are starting to get this, right? That the financial imperative, kind of the free hand, right, of the market is driving them to take actions that happen to be coincident with adopting technologies like Turntide. And I think that's really inspiring. And what's incumbent, it feels like, on venture capitalists and entrepreneurs to do is to shine a light on that coincidence, right? Because that is new. That is actually relatively new. And it's profound because that can truly drive adoption dramatically of technologies like yours.
Yeah, no, and it is really genuinely new. And that gets to that, these exponential cost curves. Like, it's funny, one of our investors, Tony Fidel, he was his first job, and there's a great documentary about this company, General Magic. So if you remember this company in the early 90s, it was a group of people that spun out of Apple, and they had all of exactly the correct ideas for the iPhone, which of course the greatest consumer, I think they sold, I don't know, hundreds of billions of dollars of product. And it was like a $400 million bonfire because, a device in 94 that, has $100 worth of memory can store 30 seconds of music or something. And that's not an appealing product, but as soon as that can store 100 hours of music, it's like, the iPod and the iPhone, and it sells 1 billion units. And so understanding, that these technology cost curves, keep moving forward and keep marching forward. And, our time sort of for switch reluctance, happened to be only feasible about 3 or 4 years ago. But there's so many other technologies, like things with like smart sensors, smart buildings, we're getting into now. And so I just think for people in the venture capital space like you, if you can really just see, hey, what's maybe, 2, 3, 4, 5 years out, and that we can fund so that by the time the cost curve comes down, it's going to pay for itself. I mean, that I'm glad there's lots of people doing that, because that's what really, gets this sort of, profitable clean tech, engine running hotter and hotter until, eventually all the carbon is gone. That's the goal.
Well, we couldn't do it without entrepreneurs like yourself. So it's awesome to chat with you, Ryan, and love, obviously what you're doing at Turntide. And we're so excited to help and introduce your technology to the commercial real estate industry. So thanks so much for everything that you're doing.
Yeah, no, great to partner with you guys, and yeah, excited about working with all of your strategic LPs.
Awesome. Thanks, Ryan.